Dear learners, welcome you all to this video of quantitative reasoning and aptitude. So this video is all about time, speed and distance, the concepts of time, speed and distance spread across 6 different lessons. Let's get into the syllabus of the topic. So the syllabus of the topic being average speed, time and distance reference, same distance questions, problems based on trains, problems based on boats and streams, and the questions based on races. So average speed and different other terminologies comes under your lesson 1. Time reference and distance reference comes under your lesson 2. Same distance is your lesson 3. Problems on trains is your lesson 4. Boats and streams being lesson 5, and races will be your lesson 6. So let's move with the lesson 1, which takes into your average speed and certain terminologies. As you all know, speed is given by distance by time taken. So whatever distance that you cover with respect to the time is your speed. And this is your speed, time and distance chart, where your speed is given by, see, if you have to take your speed is given by distance by time taken, and distance will be the product of speed and time, and as such your time is given by distance by speed. And these are the common use for speed and their abbreviations. So it is all about the units that we use for the speed. So the general units being, the general the most common units that we use is kilometers per hour and meters per second. But then you also have certain questions based on miles per hour. So this is also normal, and feet per second and centimeters per second. However, the distance covered will be your first tabulation, and the second tabulation with the time taken. So as said, speed is distance by time. So even in the units, you take the units of distance by the units of time. So as you know, your uniform speed is, see here the picture itself denotes that the uniform speed is when an object travels an equal distance in an equal interval of time. So here if you could notice, so 0 to 1 is your distance. It covers in say 1 minute, or let's say 1 to 2 another. So equal distance in equal interval of time is your uniform motion. Next comes your relative speed. Your relative speed is again nothing else but the speed of one object. When both the objects are moving, the speed of one object with respect to the other object is your relative speed. And in general, if the objects move in the opposite direction, your relative speed is given by x plus y. That is the addition of speeds. Whereas when the object move in the same direction, it is the difference of the speeds. Remember here the x meter per second is considered as greater than your y meter per second, x greater than y. So then we have taken as x minus y. So however, it is a difference between their speeds. So when we come for average speed, always remember average speed is given by the total distance by total time taken. So this is the standard form of measuring your average speed. It is again nothing else but the total distance divided by total time taken. Let's take some examples. When you have case 1 where the distance, the journey 1 take the same distance and the journey 2 is also of the same distance. So distance being the same, whereas the time being different, your average speed is given by 2ab by a plus b. So either you can take in the same direction, the car travels in the same direction, or let's take another case where the car travels from point A to point B, covering a distance of say x kilometers with some speed. Let's say the speed is a miles per hour as such is given here, and it also comes back with the speed of b miles per hour. Even in this case, it's going to be the average speed as 2ab by a plus b. Alright. Whereas in the second case, if you could observe, the distance in journey 1 and the distance in journey 2 is different, but the time again is same. So when the distance is different and the time is same, maybe your average speed is given by x plus y by 2. But when the distance is different and the time is also different, it's better to go with the average speed as total distance by total time taken. I guess the slide is very clear. See, there are different options. The standard option is that the average speed is always given by total distance by total time taken. So these are the shortcuts with different conditions applied. So when I say the distance is same but the time is different, you can go for average speed is 2ab by a plus b. That's again a shortcut. Again, I'm trying to say that if you could solve with the same total distance by total taken, again you will be getting the same thing. So since the time is different and the distance is same, this is a shortcut where your average speed is given by 2ab by a plus b. And case 2 is that the distance is different but the time is same. So when the distance is different and the time is same, even in that case you can go for average speed as x plus y by 2. But again, when the distance is different and the time is different, it's better to go with the average speed as total distance by total time taken. So here we are taking a couple of questions. For example, so here comes an example. The distance between two stations A and B is 778 kilometer. A train covers the journey from A to B at 60 kilometers per hour. Let me just draw. So this is the points which are point A and point B. The distance between them is 778 kilometers, and train A from point A to point B, that is your speed from point A to point B is 60 kilometers per hour, and returns back with a speed of 40 kilometers. So while coming back, it covers at a speed of 40 kilometers per hour. So since it is the same distance, see, listen, the distance being the same, but again distance, since the speed is different, I would better go with the average speed as 2ab by a plus b. Okay, by a plus b, where a is 60 and b is 40. So if I'm going to calculate it, I don't need the distance at all, just the speeds are fair enough for me to give the answer. So the answer can be calculated as 2 into 60 into 40 divided by 2 into 60 into 40 divided by 60 plus 40, which is 100. So I'll take off these two zeros, and 6 fours is 24. 24 into 2 becomes 48, and 48 kilometers per hour is my answer. I repeat, the distance between 2 points is 778 kilometers. It travels from point A to point B at a speed of 60 kilometers per hour and comes back with a speed of 40 kilometers per hour. So we might as well can go for 2ab by a plus b, since it is the same distance question. So I don't need the distance at all between them. So I take a as 60 and b as 40 and solve to get the answer as 48 kilometers per hour. So the next question is here. A truck travels 300 kilometers at a speed of. So let's again draw this. So let's assume that this is 300 kilometers. So this 300 kilometers, it travels at a speed of 45 kilometers per hour. 45 kilometers per hour, and again the next 600 kilometers, which is double the distance. So 600 kilometers, it increases its speed to 60 kilometers per hour. So we need to find the average speed. So when I'm going to find the average speed, see the time taken, if the time taken between these two different breakups are same, then I can go for x plus y